Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video is going to take a look at C++, object-oriented programming, an example problem. This is part one of a part 2 or 3-part project that I'm giving my students. And so those of you who are my students, you know exactly what the problem is, but I will describe it for those of you who are watching this outside of my normal class activities. So I have a backstory, and nobody cares about backstories, right? Get to the point, right? But the Boov and the Gorg are going to battle, and I need to figure out how strong I need to make my Boov to be able to survive battle with the Gorg. And so this is coming back to a movie called Home. The movie plot is it's different enough than how I'm describing it. I exaggerate on purpose, of course. But here is what we're supposed to be doing here. We're going to create a Boov class that has these requirements. So that, this is an object-oriented programming. This is part 1. So we're going to be using data hiding, encapsulation ideas when it comes to setting up this class, this Boov class, and using it. So there's 3 member variables for this class called Boov. There is a string for the name. There is an int for the health, the current health value, and there is an int for the current shield value. And so there are no default values, so that's screaming out that these need to be passed in as parameters to the constructor. You'll see in part 2 that it says that every Gorg has a specific health and a specific name, and well, that screams out, well, I don't need to pass information in since it's always going to already be George and 30 and 5 and everything else. Okay, so 3 private member variables, and then I have the constructor, and then I have get functions for each of the 3 member variables, fair enough, and then a public function for is defeated, and so a Boov is defeated when its health is 0 or negative. That's pretty simple, that makes perfect logical sense from a video game standpoint or from anything standpoint. You have 0 health, you're gone, right? So. But the hardest part of this, the most challenging part, will be this gets attacked function. So there's 4 different things that can occur, and say we're simplifying this, we're just rolling some dice to see what happens, and just think of it like a 100-sided die, and be like, well, 1% of the time, headshot, right? You're instantly defeated, poor guy. Instant health to 0, he is now defeated. 20% of the time, the attack misses and does nothing, which, just complete miss. 50% of the time hits the shield. Just think of you holding a physical shield, and it does random 2 to 5 damage. And so just think of it like a physical shield, like I'm saying. And if that shield is reduced to 0 or a negative value, that means the shield's been destroyed, so it's essentially useless. So that damage would go to your health, because it's basic, with a damaged shield, it's hitting you instead of hitting the shield. And 29% of the time, the attack does random health damage. It basically just bypasses the shield altogether, doesn't even affect the shield, hits your bare body, and it does 4 to 8 random damage. And so the code itself, I've given you the runner, the main function. This is the slide. There's 3 slides that show this. So what you're going to do is enter a health value for the Boov, enter a shield value for the Boov, and then the computer is going to go ahead and run 100,000 or a million or who knows how many simulations, checking to see, based on that starting value for how many health and how many shield, how many rounds can this Boov take before they're defeated, following the rules for the isAttacked function that we just created. And so, and then say the end result is we're trying to find out, maybe it doesn't say so here, but let me show this real fast here just so you can see all 3 pages. But the end result is the final question is how many, presuming 13 shield. That is something I should have put in the stupid PowerPoint here. But anyway, presuming that you start with 13 shield, what health value do you need to have to survive 12 rounds of battle on average? Because of course it could be 1. You roll a 1 right off the bat, you're done. But on average, if I have only enough money to give a Boov 13 shield points, how much health do I need to train them to get them up to the point where they can survive 12 rounds of battle? So that is our starting point here. Okay, so I have all I'm starting with over here in Visual Studio is the C++ file that I just showed you, and you can see that nothing works because I don't have any Boov files open and ready to go. I have the runner, and so this presumes if you put everything in correctly, it'll run correct, and you'll get some results. And so this is our starting point. If I run this, you get a compiler error because there's no such boov.h. So let's go ahead and set up the boov.h, and then from there go on to set up the boov.cpp. So I'm going to go ahead and add a new item, boov.h, as I'm saying here. And that, of course, doesn't immediately go, oh, now my program will run. You know, it's like, okay, but now doesn't know what a boov is, and even though I have that file, so at least one of those errors goes away, right? That the whole point of programming is to make those fun errors go away. And so, yep, it doesn't know. But let's come in back here, pragma once. We'll need a class boov. I can spell, I really can. Okay, I need some public stuff and I need some private stuff. Make sure you leave this pragma once in. Those of you who know what include guards are, that's exactly what it's doing. It's doing so in a Visual Studio Windows kind of way. And it just means that this doesn't get compiled more than once because there's things, you know, the compiler hates it when it sees the same thing more than once, right? Like if, you know, int a, compiler error, and that's where this is coming from. It's just a way of guarding it so the compiler will see this and go, oh, I've already compiled it once. I don't need to do it more than one time. Okay, so we said that there's going to be a string object for your name. And I'm get this out of the way ahead of time. I'm going to need to include string. Some of you had some weird errors that didn't. That weren't weren't apparently clear what was going on, but you need to include string inside here to use that. I'll need an int value for my health and an int value for my shield. Okay, and so now let's say I'll need get functions for this, that, and whatever. So get name, and then I'll need an int value for get health. I'll need an int value for get shield. So those are the three getters. I need that bool function is defeated. And if you want to do const, we'll do it the right way. Put const here for everything because I'm not going to be the get, right? I'm just getting information. I'm not modifying information. And the same would apply, but the void function gets attacked. As you can imagine, variables are going to change under the hood, so this is not going to be a const function. And so I also need a constructor for boov, and as I was discussing, there's no defaults for any of the three variables, so it makes sense that I would pass along everything by into the three parameters into the function here. Let's say name, int health, int shield. Oops, child. Okay, so, and I did this, I'm passing strings and objects by reference, const reference, so it doesn't, so C++ doesn't make a copy of the string before I go ahead and make a copy of the string. And so it's passing a reference, passing a memory address along where the real string is, rather than copying the string object and wasting processing power. And I believe that is all I need. That's a part 2 thing here. Let's see. I have the 3 member variables, the constructor, 3 gets, and 2 functions on top of it. So yes, it would appear that this is everything that we're looking for when it comes to the .h file here for the Boov class. And what's, is it surprising now? If I go to run this, I'm like, I got everything in here. What happens now? I had all these compiler errors. But now I have all these things called linker errors. And what that's, linker hell is sometimes the worst kind of hell. And it just, because you're like, well, what the heck is wrong? Because what happened is the program compiled just fine. But what does a compiler actually do? And so that's, what does it actually do? And so the compiler actually goes file for file, and first it's checking for its syntax to make sure you followed all the rules, all the semicolons are there, and everything's there, that you can find all the variable names and such. But this Boov class header is essentially like a prototype for the Boov class. It tells me everything that the Boov can do, just like a function prototype tells me everything that the function can do and we learn about that in chapter 6 in pretty much every book that I've ever used when it comes to teaching, C++ programming. And so when it comes down to it, when it says, oh, and down here, oh, set up a Boov. And like, okay, this thing exists. Here's my constructor that takes 3 parameters. There's my constructor that takes 3 parameters. So at the compile stage, it says, yep, that's fine. That's good to go. But what happens later on is when it gets to linking it all together, it's like, okay, you promised me this function and you told me it exists. Well, now where's the implementation of that? I need the actual implementation of that, and that's where it goes wrong. And so every individual file compiles perfectly fine, but when I try to tie them all together in the end, that's where the linker errors come from. And so now we need to fill in these gaps here. So what I'm going to do here is highlight quick actions and refactoring. I'm going to create declaration and definition. And so oops. What is going on here? Hold on, let's try this one more time. Right click, quick actions, create. Requested operation failed for 4 of 6 functions. I have never seen this before in my life. What is going on? What is wrong? Bool is defeated, const, semicolon, void gets attacked, semicolon. How odd. Yeah, it's not even turning green. What am I doing wrong? And so I generally enjoy, I don't enjoy errors and bugs and things like that, but I don't tend to edit these kind of problems out, because if I experience them, and I've been working with computers for 20 years, you guys will experience them too, and I will take a look at this and I will get back to you as to why this is wrong. So it turns out the problem was just because I was using something that was pre-used when it came to projects. I deleted some stuff out. So Visual Studio, it's a Visual Studio issue, so you guys should not have this issue if you're starting fresh. And so you can just go ahead and go in here, right click, quick actions, and do create declaration / definition, and it will generate all this cool stuff for us here. And so I can mouse this over, move this over, so now we can see everything. And now we can go ahead and fill in all the details. And so the gets are pretty simple. Return name, return health, return shield. We don't actually use them for anything, but there they are. Is defeated if health is less than or equal to 0. Return true, you're defeated. Otherwise, return false. So you would be tempted to do something like this. Something like that. Be like, okay, fair enough. But first off, if I see a return here, then the function's going to end. So there's no need for an else. So that's our first step. Like, okay, if I don't return true here, I'll fall through and go, oh, I'll return false, because the health has to be greater than 0. Because that's what happens. This is, the true falsiness, the Booleanness of this. And so you're like, well, okay. But then this guy right here, this relational operator, returns a Boolean true false no matter what. So you're saying if true, return true. If false, return false. You can just go ahead and one-line this thing. And there you go. That's a one-liner. You don't need to do anything more than that. So this will always return the bool, the true falsiness of this. And as for this, setting up the member variables using an initializer list, the name is going to be set up to whatever the name is coming in. The health is going to be set up to whatever the health is coming in. And the, and the shield is going to be whatever the shield is coming in. And everything's going to be set up here, so there's no need for anything inside the body of the constructor. And you will see that, is it not happy? What is it not happy about now? I think it just, let's rebuild it, see what happens. All succeeded. Yeah, visual, there it goes. IntelliSense is usually behind on these kind of things when it comes to this. And so we're going to see there are times where we do need to use the body of the constructor, but we don't need to, we just use the initializer list to set up the 3 member variables. And because we're not dynamically generating any memory, we're not newing anything up, there's nothing fancy in this, this class, we do not need a destructor, at least in the way that we're using our everything right now. And so the final step, say we could run this right now, it'll infinite loop on us, but now it will run. and there's my enter Boov health value, 31, and there's my shield value of 13. And I go, okay, and the reason why it never ends is because it's stuck in here. Nothing ever, the health value never is modified. The shield value is never modified because we haven't fixed that up yet. And so if I just go ahead and F10, come back, you can see I'm just stuck in here forever. How many rounds have I done? Oh my goodness, how many rounds of nothing have I already done? That would be great. We would have the best fleet if we could never get it, if they could do no damage to us, but that's just not how things are going to work. So the final step is to fill in this gets attacked function, and part 1 will be complete. Okay, so I've gone ahead and brought over this so we can see what's going on, so we can see what we're trying to implement. So we'll say what's the, this is not how I would set it up. I'm just gonna plow through it. But if I were doing this for real for efficiency value, I would be doing things in a different order. But I'm just gonna go with what we've got here. So I need, and we're going to use rand. You could, if you know all the fancy C++, the new fancy C++ stuff for random number generation, go ahead and use that. But I'm just going to use plain old boring rand, knowing full well its limitations and all of that good stuff. So I'm going to need a value. So I'll roll my roll value. Just say I'm rolling a 100-sided die, and I can just say give me something between this. This will give me something between 0 and 99. Some people add 1 to it. I mean, it doesn't matter as long as you know what you're trying to accomplish. I'm just going to leave it alone as is. And so here I'm going to say if the roll is 0, then set health to 0. So this might take a while, but this will run now because 1% of the time I'll die. So on average, you should be able to take, no matter what your health is, you should be able to take about 100 rounds on average, because 1 out of 100 shot to kill you. Let's see, 31, 158. I don't know how long it'll take to do all of this. I'm just hoping it doesn't take an infinity amount of time, but I can put a breakpoint in here and go, yep, at least it's working its way through. It's finding. Oh goodness, it is very slow. Come on. You can fast forward through this. Well, some of you, I hope, are fast forwarding through this anyway and just kind of running this at 1.5 speed, because I never know what's going on. So let's see. My goodness. It is running through a whole bunch of things. Okay, let me simplify this by just going back. I want to see this. I want to see that I'm getting about a 1 in 100. I'm going to change the number of simulations. Oh goodness, I accidentally set the number too large. That's all it was. And so, oops, 31, 30, whatever. And there you go. The average number of rounds is never going to be perfect, but it's about 100, because every 100 times I go into that function, I'm going to roll a 1, and I should fall out. And so just based off that, I know I have things going, things are going correctly so far. And this guy right here works. I'll get rid of you. The 20% of the time, do nothing. Okay, done. Do nothing. You never write code that does nothing. You always write code that changes variables and does calculations. But there's no reason to apply it if it's going to end up doing nothing and have empty code, an empty code block. So 50% of the time. Else if my roll is less than or equal to 50. Because this is going to handle, this is obviously handling just 0, which is 1% of the time. But then this handles, because it's an else if, this will handle all values from 1 to 50, which is 50% of the time. That's 50 possibilities. So what do I do here? Shield does 5 random damage, 2 to 5. Shield minus equals 2 plus random, rand mod 4. And so what's going on here? So this rand mod 4, just like this gives me a value from 0 to 99, this will give me a value from 0 to 3. And so if it gives me a 0, I'll get a 2. And if it gives me a 3, I'll get a 5. And there's my 2 to 5 damage. And so all I have to do here now is say if my shield value is less than 0. Because if I had 4 shield points and 4 damage was done to it, well, the shield did its job and I suffered no damage, but my shield is completely broken. It's only if my shield ends up being a negative value that I have to worry about the fact that now I'm going to do health damage, And this is weird because the shield value has to be negative here. So I'm going to actually add it in, even because it's going to be negative. And then I have to make sure, because there's no such thing as a shield with negative value, set the shield to 0 so the next time the shield gets hit, all of the damage will be done to the player. And so with this in place, let's bring this up and say, okay, 15 and 35 or something like that. You can see now we're getting lower because, yes, I'm getting more damage. So about 25 rounds with this health and with this shield value on average. So I think, that's pretty good. 50% of the time I do 2 to 5 shield damage, and if the shield is gone, I do health damage. Okay, fair enough. Else if, I can't just do else because, again, I eliminated those 20% possibilities here. But if the roll is less than or equal to 79, because this handles everything from 51 all the way to 79, so that's 29 possible values. So 29% of the time, health minus equals 4 plus rand, let me put one more parenthesis here, mod 5. And so if this does 4 damage, if this is a 0, oops, I need one more parenthesis. If rand mod 5 gives me a 0, I get 4 damage. If it gives me a 4, then I get 8 damage. So this will give me everything correct within the 4 to 8 realm. And as you can see here, coming back to that, coming back to the 20% that does nothing, you'll see that if the roll value is anything 80 and above, 80 to 99, those are 20 values, 20% of the time do nothing. And then we actually do nothing, right? Because we handle the 0 case, we handle the 50% case, we handle the 29% case. And if it doesn't fit any of these, if, else if, do nothing. And so now, if I did everything right, we are good to go. And we come back to this, I said, okay, let's just give a 15 health. I say, okay, 13 shield was what we were going for. And I go, okay, oops. The Boov can survive 7.5 rounds on average. And so let's try this again. They say, how about 20 and 13? And I go, oh, better. So we're just going to continue on. And let me up this a little bit. Let me just bring this back because it wasn't working a second ago, or it was going way too slow anyway. Let me bring that back up to 1,000,000 runs. And so try this again. And say, okay, how about 25 and 31? I'm sorry, 13. 13 shield. And you go boom, boom, boom. 10.5 rounds, getting better. How about 30? Bring it over. And you're like, what are we at? 11.87. We're right there. Let's see if 31 does it. 31 with 13 shield, running through 1,000,000 simulations. There we go, 12.1486. There is my answer for part 1, and I've wrote the code that takes care of everything. I've written the code that takes care of everything, and it proves it simulation-wise. So if I'm giving every Boov 13 shield, on average, I have to, to survive 12 rounds of battle. There's no, there's no partial rounds of battle. So to survive on average 12 rounds of battle, I have to get my Boov's health values up to 31. And so we need to do some training. We got to get out there, do some laps, do some strength training, whatever we got to do, get our health to 31 points so we can get you to get you the 12 rounds. So that's what I was looking for part 1. And so now with that said and done, now we're going to move on to part 2 for the next video, add in the Gorg, and then start battling them and seeing what happens based on their stats versus my stats. Who will win based on the stats of 31 health and 13 shield versus the Gorg stats? Who will win more often, the Boov versus the Gorg? I can't wait to try it, and we'll see you again in that video. Thanks everybody. Have a great day.